Good afternoon, everyone, and welcome to today's Creative Technologies seminar. Our topic today is Beyond the Limits of Human Touch. My name is Juliana Harkki. I'm a doctoral researcher in the Department of Neuroscience and Biomedical Engineering, and I will be the moderator of this seminar today. We have two great speakers today. And our first speaker is Professor Francis McGlone. He is a visiting professor in the Liverpool Neuroscience group. He's a neuroscientist with a primary focus on somatosensory systems and the nerve fibers that code for touch, pain, and itch. He pioneered research into a class of nerves that code for pleasurable touch, and he has published over 300 research papers. Welcome, Francis McGlone.
Thank you, Julia. I'd like to thank the Creative Technologies Consortium for the invitation to give this talk. And hopefully I will change your lives in some small way when I give you some evidence for the fact that touch is a lot more complicated than you think it is. So, touching and feeling, this title, Two States, Two Systems, is a sense of touch you all know about. You know, if a fly landed on your nose, you'd feel it. Most people think that that's the sense of touch. Well, it's far more interesting than that and far more complicated. This is quite pertinent, by the way, this little joke, because we're moving into a world now where touch is becoming more and more demonized and less available because of these smartphones and touch screens. We're missing something.
Science fiction novel, The Naked Sun. Isaac Asimov invented a world, Solaria, in which a tiny fixed population of humans live out their days on enormous estates, waited upon by scores of robots. The Solarians' social ambience is something like that of a 19th century Russian novel. A scrupulous attention to social mores and rankings is only enhanced by this bizarre fact. Delivered from material want, or the requirement for sex, all procreation is scientifically managed in birthing centres, a la Brave New World, they have evolved a severe taboo against physical proximity of any kind. Indeed, the Solarians never even occupy the same room together, let alone touch. And
that was Asimov in 1957. That's quite prophetic because that is the world that we're moving into. And I'm going to explain how dangerous that scenario is. So we all know the skin's our largest sensory organ. These are the things we know intuitively about sting in terms of tactile exploration, assessments of textures, silk and wool, etc. And also comments that are quite germane now. The Nobel Prize last year was awarded for the first discovery of how touch, mechanical stimuli, are actually encoded by cellular systems. So this whole field is lighting up now, understanding more about the mechanisms that are pertinent to how human beings or any animal detects touch. And you know, artists and writers have often made comments about how touch is a language, as Margaret Atwood always tells the truth. You know, if you look at a vase of flowers and you don't know whether they're fake or not, you'll touch them as the arbiter. So why study touch? Well, it's fundamental to the human interactions. And there's a couple of examples here how just touching somebody gently can change their behavior. This is done quite implicitly or not intuitively. You know, there's the subliminal touch by a waiter who just, when they're giving you the bill, they gently touch you, you give them more money. These are the disciplines that are basically coalescing around how the sense of touch can be investigated. And you'll see down there, art and design and virtual reality. We're trying to simulate or emulate tactile interactions now. And what I want to describe is how complicated that process is. So as a neuroscientist, this is the bottom line and what you'll get from my talk today, is we've discovered another sense of touch, which is playing a fundamental role in the social aspects of affiliative behaviours, and it's a nerve fibre. So, a quick look at the skin. We've got two types of skin, basically. We've got the skin on the palm of the hand and the soles of the feet and the lips is called glabrous skin. The rest of your body is covered in what's called hairy skin. Even though you don't see any hairs, you're covered in hairy skin. This is a critical anatomical distinction for my talk, is that there's a nerve fibre in hairy skin which is rarely discovered in glabrous skin. And it's this little C fibre that I will be exploring in terms of my interest in touch. So the hand really is the haptic domain. This is where you feel objects, this is where you're manipulating tools. It's all of this quick stuff that you're trying to evaluate the world around you in terms of objects that you're handling. And of course, we know that this tactile system is represented in the human brain disproportionately because you've got more receptors on the fingers and the lips, so there's more brain power allocated to processing. But the interesting for me is this hairy skin, and that's the affective domain. This is where this nerve fibre that responds to gentle touch is more generally found. If you just read some of these comments here, I gave a talk to the British Psychological Society a few years ago where I made out that not touching a child was a form of abuse. It's not good to Google my name, McGlone, and child abuse with the wrong connotation. I even got onto the BBC one morning where I had to defend.
Thanks, Carthy.
Carthy, thank you. How much physical contact is acceptable between a pupil and a teacher? If students are upset, should teachers comfort them, or is any contact too much?
Well, according to the neurologist Professor Francis McGlone, educators who are too scared to even give children a reassuring pat on the shoulder are guilty of abuse. Well, he joins us in the studio, along with Executive Head Teacher of the Education and Leadership Trust, Patsy Kane. Welcome, both of you, to the programme this morning.
Anyway, the executive head teacher didn't really agree with what I was saying because she was instructing the teachers not to touch a child. If a child falls over and hurts itself, don't touch it. So that comment underneath it, this demonisation of harmless touch, may be a carryover from Puritanism, in which the American satirist Mencken said that having the fear that some people may be having some fun, and touch is giving that affective dimension to our lives. All animals have some sense of touch. All of them cuddle, nurture, etc., including obviously humans, not only in the rearing of babies, but in the making of babies. I like to look at comparative physiology. Here's an example of a little worm. It's got 340 neurons just about. But if you grow C. elegans in a colony where it can touch each other, they grow to their normal length. If you grow C. elegans, this little worm, in isolation, its growth is stunted and its behaviour is changed. So what's missing in the little worm on its own? Touch. We'll pick this up later, by the way, with preterm babies. What's the mechanism? This is an interesting one that some scientists looked at the solitary behaviour of the octopus and they put ecstasy, MDMA, in the tank. And rather than playing with the toys and basically playing on its own, all these octopuses started playing with each other and touching each other. So here we have a link between serotonin and affective touch that anybody who may have taken ecstasy might be aware of. What's the mechanism? This is really germane to this argument in that the epigenetic element. This is work done by Michael Meany many years ago, who showed that highly nurtured pups, i.e. you can have two types of rat mothers, those that lick and groom their pups a lot and those that ignore them. Those pups that get licked and groomed a lot, and this is touch again, grow up to be sort of normal behaving rats. Those rats that didn't get much touch grow up to be anxious and aggressive. So there's a link here between early exposure to touch and epigenetically the expression of behaviour over the lifespan. Again, Meany didn't know what the mechanism might be for this. You all know about Harlow's stuff with these monkeys that were removed from their mother at birth, given the opportunity to feed from a wire surrogate that had all the fuel, where that monkey should have been, or a cloth surrogate that had no reward associated with it, because these monkeys instinctively clinged to the soft surrogate. Even at birth, these babies are just born, they're seeking soft touch comfort. Again, what's the mechanism? And just one final for the primates, the bonobos are closely related to humans. They spend a great deal of time touching, and they're the most passive and peaceful of the primates. The ones that don't have that kind of behaviour are actually aggressive. So domesticated qualities, their capacity for terrible violence, can be reconciled by the early exposure to touch. So bonobos touch a great deal. And moving closer to home with studies recently on the Romanian orphanage babies and the removal of a child from its natural nurturing environment and placed in these cots, there's a lot of evidence now that these children, although they're fed and watered, they do not develop normally. They are all suffering serious neurocognitive deficits. When these babies were discovered in Romania orphanages in the 1990s, when they were placed in foster care, their behaviour improved significantly. But the later that happened, the worse the prognosis was. There are critical periods in the very early life of a baby where that touch is absolutely critical, the way that that brain is wiring up its sense of self. And James Prescott, who worked at the NIMH, had a very strong theory that somatosensory deprivation ultimately leads to violent behaviour in adulthood. I'm now convinced that deprivation of physical sensory pleasure is the root cause of violence. So I don't know how many of these influential psychologists in the 1950s in North America, J.B. Watson, I love these comments. You know, never hug or kiss your kids, give them a good stiff handshake. An untouched child would enter manhood bullocked with stable work ethics. Oh my God. However, if we look at his own children, he had 2 children with his first wife, one of whom attempted suicide in later life, and also his second wife, his kids, who were following his mandate and how to bring a child up, basically didn't fare too well either. So beware of advice from people that have no real understanding of what they're talking about. And just finally on this building this case, loneliness is becoming a more and more significant problem, particularly in countries like North America. More and more people are living on their own. What don't lonely people get? They don't get the physical contact that they would normally get in a more social environment. And the odds ratio of an early death from loneliness is 45%. It's higher than smoking. So again, there's something going on here, and this is what I keep coming up with what's the mechanism. And this is just a recap what I've just said about the argument I'm building now, that there's something going on here. It's a bit like trying to find out a clue in an Hercule Poirot sort of example. So the common thread is gentle touch. I'm now going to tell you what the mechanism is. So we have 2 types of touch. The one we know most about is the discriminative one. This is the one that tells you that somebody's touched you. This is coded by fast myelinated nerve fibers. So if somebody touches you, feel it immediately. This is all about detecting and discrimination. And we know where this maps into the brain, etc. We know a fair amount about these receptors that code for discriminative touch. However, we have another population of nerve fibers in the skin called C fibers. C fibers are unmyelinated nerve fibers, and unmyelinated nerve fibers send information to the brain very slowly. The classic example is the nociceptor. You know, if you put your finger on a hot plate, the fast pain system pulls you back. If you're me, you'll probably swear. But then you'll know a minute later, boom, boom, that emotional experience of pain. It's coming much later, and it could be there for an hour or 2. That's what C fibers do. They provide emotional input into the brain. So, going back to my Swedish colleagues, in 1939, a Swedish neurophysiologist called Zoterman discovered a C fiber in a cat's skin, I think, that responded to fast touch, which he would have expected. Then on that second trace, you can see spikes coming along that nerve fiber in response to that stroking touch over the receptive field of this nerve fiber, a mechanical response to stroking touch. Then over the ensuing decades, this nerve fiber was found in other mammals, and then ultimately it was found in humans by a Swedish neurophysiologist. Only in the late 1980s, this nerve fiber was discovered in humans, and they're called C low-threshold mechanoreceptors. In my group, we study these nerve fibers using a whole range of techniques. The one I'll focus on is microneurography, coupled with psychophysics, and also using functional brain imaging to look inside the brain. This little robot took a couple of years to develop, probably cost $500,000, but what we wanted to do was deliver stroking touch at known velocities and forces to different body parts and ask people, how do you feel? And we were the first people to actually try that. So the microneurography is a phenomenal technique. It's like wiretapping a peripheral nerve. You put an electrode through the skin into an underlying nerve bundle, and you can listen into conversations coming down different classes of nerve fibers. They could be touch, temperature, pain, itch, and this is where the C tactile was discovered. And its response is here. We coupled our robot with the microneurography, And what you can see here, you can just see those electrodes poking in through the skin, into my skin actually, into an underlying nerve bundle. And we found a low threshold mechanoreceptor. The robot strokes across its receptive field. You get that response from the unit. This is touch at the encoding level that your brain is interested in. And this is the lovely Rochelle Ackerley, who is really skilled in recording from the CT. And here you'll see a response, a fast response and the slow one. And dependent on the velocity that Rochelle is stroking that receptive field, that nerve fiber is far more excited by a slow stroking touch than a fast stroking touch. This basically shows these two types. This is a fast one. So every time the receptor is this is what you feel it. You see tactile afferent, the slow touch is on the right, and there you'll see a different kind of response. There's a definite delay now between that physical stimulus and how that's actually working. I seem to have got copper. Anyway, what you're seeing here, never mind. That nerve fiber loves slow touch. So what's the functional role? Why are they there? They're slow conduction velocity, they have variable responses, they're not present in glabrous skin. We've found one or two possibly, but they're not functional. They're not pain receptors. People thought these were just another class of nociceptor when they were first discovered. But decades of work has characterized these nerve fibers as being absolutely fundamental, and they exist. So this is the first study we did where we asked people, is it sensible to even ask if people like touch? So we took our robot and we stroked it different velocities across the skin, and participants just said, how pleasant is that? And what we find when we look at a psychophysical response is that at 5 centimeters per second, people rate that touch as more pleasant than fast or slow. And on different body parts, there's a different emotional ranking. So when you're stroking across the face, that same physical stimulus is reported as being more pleasant. There's probably more of these nerve fibers here than here, is what we would intimate from that. So the psychophysics and the microneurography were then put together. This is like a 4 or 5 year program where we recorded the response properties of this C-tactile afferent, and that's that graph there on the left. And what you'll see at certain velocities, like 3 centimeters per second, the nerve fiber is firing more effectively than fast or slow. If this was the first touch system, the faster you stroke, the more the nerve fires. We then take our psychophysical experiment and we ask human beings, which of these velocities do you like most? And we find exactly the same functional curve, that quadratic effect. And that basically was our social touch hypothesis, the pleasant touch hypothesis. So those papers you can see there. This is the wiring diagram if you want to know how these things get to the brain. We still don't quite know where they project. So effective touch, just to summarize that initial didactic element here, of slow conducting unmyelinated nerve fibers found primarily in hairy skin. The optimal stimulus is gentle touch. They're also beautifully tuned to temperature. So they will fire more to a skin temperature touch than cooler or warmer. So who doesn't like cold hands? So in human infants, gentle touch we've shown reduces pain, increases vagal activity, even impacts on the immune system. This nerve fiber is doing a hell of a lot of work in the very early stages of life and development. This is an example of a study we've been done looking with mothers just stroking their babies, and there's a reciprocal relationship between heart rate synchronicity and that baby and touch. This tactile interaction is cementing an interaction which is effectively measured by a marker here called respiratory sinus arrhythmia, which basically is a measure of relaxation. So when these mothers are touching their infants, we get this change in heart rate, which is linking at a level of relaxation between the mother and the infant. And interestingly enough, that bar on the right shows that this effect keeps on growing after the mother puts the baby down. So this C fiber, like my pain nerve, is responding way after the event has happened. One way we wanted to get it, how we can prove that gentle touch is providing a really important level in regulating stress. This is a fundamental property of this nerve fiber, is regulating stress. So I had a collaboration with a guy in Chile who had stress models of rodents, and I convinced Alexis to basically take a group of rats every day, stroke them for just 10 minutes at what we think is the velocity of this nerve fiber in a rat. Another group was stroked like that, Another group were basically just left alone. And over 2 weeks, they were subjected to a chronic mild stress paradigm. 10 minutes of touch every day, but lights going on, smell of cats, basically a stressful 2 weeks. At the end of that 2 weeks, we put them through a number of behavioural tests. And those rats that had the stroking touch, when they're put into this water bath experiment and you're measuring cortisone, they behaved exactly the same as the non-stress rat. The stress rats, the cortisone levels were through the roof. 10 minutes of touch a day had regulated this animal's response to a stressful situation. They were resilient to stress. Another test we showed that this is the anxiety-like behaviour. A rat won't walk across a high surface if they're anxious. Here we see these rats again, were just chilled. All they had was 10 minutes of touch every day. So what our next steps really are to try and look at how we can unravel the circuitry in rodent models, but also take that understanding of this nerve fiber's response properties into human studies. And this is where my interest in preterm babies is basically focusing at the moment. This is something I'm hoping to develop with Aalto here. And as a neurobiologist, I'm always interested, if you want to understand an animal's behavior, you put it in the environment that it's evolved in. Let's look at the preterm baby. When those babies are removed from the womb, obviously for clinical reasons for the baby's life and the mother's, and placed in an incubator, what do you think's missing? You see, if you didn't know this nerve fibre existed, you wouldn't know that it needs to be stimulated. Those babies that get gentle touch put back in the incubator, those babies' brains develop significantly differently and better. So what I've done is developed a device that will basically be placed. This is a prototype. This mattress here basically will be placed underneath the baby, and these preterm babies will be placed on this stroking mattress, and we'll put the touch back that infant would have been receiving in utero, with the amniotic fluid rubbing over its skin and the movement against the womb wall. And what we're hypothesizing is that this will make a significant impact epigenetically on the expression of stress receptor systems in the human brain, as well as things like serotonin and the baby's immune system. So that's the future in terms of how we can take this device, take this understanding of this nerve fiber's relevance. Just to give you an example, if you don't know what you don't know, there was an operation done in the 1980s by neonatal surgeons. A little baby Jeffrey had a heart defect. They took baby Jeffrey, slit him open, lifted the lung out, tied this blood vessel up together again, sewed him back up and put him back in his bed. Do you know what he had? He had an anaesthetic and nothing. He had no anaesthetic. He had a muscle relaxant, yeah? That baby was wide awake in terms of nociception for that whole operation. He died a few days later. But the neurosurgeon didn't think the C-fiber nociceptive system was functioning. I'm going to make the same argument about this C-tactile system. If you don't know it's functioning, you don't know that it's absolutely critical for early stage life, for that baby's brain to know that it's got a body and hence self. Because 25% of preterm babies develop autism. Many of them will have some kind of neurodevelopmental deficit, not always extremely noticeable, but there are legacies of that preterm birth, which I think we can fix if we put touch back. This is just a bit of humour for the British.
Hello, love. Do you have to do that?
Oh, can't a daughter give her old dad a hug?
I'm not a huggy person.
Oh, you're all stiff and knotted up.
Oh, that's normal for me.
You've got too much stress in your life, Dad. You know what's good for relieving stress?
Valium.
A big hug.
Hugging is a continental affectation, like cheek kissing and croissants. In England, we shake hands. A manly handshake is just as good as a hug. And it stops us catching each other's germs.
Well, I don't care. I'm going to keep on hugging you whether you like it or not.
I got immediately. I want you to give you a real future now. I came across a colleague who worked at the University of Lethbridge in Canada, and he had these Alzheimer's disease models of mice, and he was taking these mice and he was just stroking them every day for 10 or 11 days after they'd been stressed. He knew nothing about this nerve fibre until I told him that the evidence that he was getting from these studies that reversed the effects of Alzheimer's disease on plaque formation. Basically, plaque formation was reduced in these mice that basically got stroking touch. Now, this really is interesting because, again, he didn't know what the mechanism may be. So, this nerve fibre is playing a role which is almost unbelievable in terms of its importance across the lifespan. But what we need to do is to invest more and more in trying to understand how that nerve fibre actually is providing all these benefits. And the other experiment that Brian did was actually brain damage in a mouse model, so sucking out a bit of the prefrontal cortex, using a lot of behavioural experiments to look at these mice that got the sham operation and those that had the actual operation. Again, just by delivering touch, those mice recovered function. And when he looked in the brain at the neuron development, these neurons are also improved in their synaptogenesis. And again, all he's done is that. So there's a story here, I think, that needs to be more broadly sort of broadcast, because we're living in a world now where this is no longer available. I've christened this little nerve fibre vitamin T. You know, if you were deficient in vitamin C or vitamin D, there'd be symptoms and we give you the vitamin. I think COVID demonstrated very clearly that many people were deficient in vitamin T. They weren't getting enough touch, their stress levels go through the roof. And I don't know what happened here, but in the United Kingdom, everyone went out and bought bloody dogs. Why did they buy dogs? They needed to stroke something. Anyway, thank you for your attention.
Our next speaker is Xiao. She's an associate professor at Department of Information and Communications Engineering here at Aalto. She got her doctoral degree in computer science here in Aalto in 2012, and her research interests include edge computing, wearable sensing, and extended reality. Welcome, U.
Thank you. Yeah, thanks for the introduction. And it's really a great pleasure to come here to discuss a very exciting area of research and innovation. That is wearable haptic interfaces for extended reality. So extended reality technologies such as virtual reality already offers remarkable visual and auditory experience. However, the sense of touch is often missing. So how can we feel the virtual objects in extended reality? That's where the wearable haptic interfaces come into play. So wearable haptic interfaces comes in various forms, like gloves, vest, full-body suits, and they could replicate the sensation of physical interaction with objects. So they allowed us to sense or feel the size, the shape, the texture, and also the weight of objects in virtual environment. So you can imagine that with this kind of devices, our XR experience is going to be more intuitive, more engaging, and also more practical. And in practice, there are two types of haptic interfaces nowadays. The first category called kinesthetic devices. So this kind of devices mimic the resistance of force encountered when interacting with objects. So you can imagine that they often have, for example, some exoskeleton structure that connect to major joints of your body, like your fingertips, your wrist, your waist, like that. And they incorporate some motors and brakes into that to generate this force feedback. And the other category is called cutaneous devices. So they deliver the sensations directly to our skin, using methods like vibration, electric shock, ultrasound, or thermoelectric generators. And a typical haptic interface comprises sensors, actuators, and a control system. And to show to you, the latest advancement in this field, I have selected 3 commercially available products as illustrative examples. So the first example comes from Sense Glove. They have Sense Glove Nova. And by the way, they have actually a newer version called the Nova 2. And since I didn't find a very detailed spec, so I decided to use Nova still as an example. And this Nova glove, it offers force feedback through magnetic friction brakes. So there are 4 brakes dedicated to each finger from your thumb to your ring finger. And then with this kind of breaks, it kind of could simulate the different sizes and stiffness of objects. Additionally, it has two vibrotextile actuators located on your thumb and also your index fingers, so they could recreate a vibration. And you can see from the picture that they have many wires, and by measuring the extension of these wires, they could also provide a pretty precise, let's say, finger tracking. So the second example is called Haptic gloves G1. It's come from the company called Haptic. And this is a bit different. So this system consists of air pack. You can see like a box in the middle and a pair of gloves. On each glove, they have 135 textile actuators. And how it works is that they have this compressed air controlled by this air pack, and this compressed air would then power all these actuators. And this actuator displace your skin up to 1.5 millimeter to apply physical pressure. And that way you can feel or sense the texture of objects. And this glove G1 also offer a force feedback using the technology called microfluidic actuation. And they also support the magnetic motion tracking. And the third example is Tesla suit. I assume it has nothing to do with the Tesla car. And this provides the full body haptic feedback using electrical muscle stimulation and transcutaneous electrical nerve stimulation. So you can imagine this kind of electric pulses. So through these pulses, it emulates the mass of objects. And this suit, you could also use it for monitoring, for example, your heartbeat rate or your pulse rate. And you can see these different devices, they use different technologies. They are very complex. And another thing is they are very expensive. So if you are a student or is a researcher without a lot of funding and you want to, develop some haptic, let's say, feedback for your VR, and you want to buy this, then you might easily spend like 10,000 euro for these devices. So our journey into this world of haptic, I would say, began with just a curiosity, and we just wanted to see if we can create our own haptic devices and make them open source. So then, actually in spring 2021, we came across an aerodynamic, and he graduated from Aalto Arts, and his VR project called the Love Simulation Eve. And simultaneously, actually, Vanting is also the art student, but with engineering background. She was looking for a master thesis topic. And then we decided to join our force and created a vibrotextile gloves or feedback for this Eve project. And that is how we started the journey. And actually, after a couple of brainstorming sessions, the idea began to kind of take shape. And we got some concrete scenario. For example, can we let users feel their own heartbeat? Can we let people sense the raindrop on their palms? So this kind of scenarios. And as we are from ELAC, we are engineer, so we always made a wish list from engineering standpoint. So we aim to craft something reconfigurable and extensible, which means that designers and engineers would be able to create diverse vibrotactile feedback using the same hardware and open APIs. And of course, there are other essential criteria, like we want this to provide high resolution, to be wireless, be cost effective, and to be wearable as well. So our wish list was quite long, and we started by selecting the right motor, like vibration motor, to use and also determine their placement. We opted actually, and what we need to take into account is that we want these motors to be very small, very thin. So that's why we opted for this coil vibration motor with the smallest size we could find at that time. And regarding this placement, we eventually settled on 18 motors, so including 15 on the palm and 3 on the back of the hand. And for your information, actually at that time, the commercial ones had up to 5 motors. In the literature, somebody had tried 15, and we went with this 18. So then, when we have selected this one, we actually still went through 4 iterations in terms of hardware prototyping. And as many others will have do, the first thing is that we wanted to make a quick and dirty prototype, and we went to the electronic workshop to see what kind of component we can find from there. So we built the first one. You can see we just put the 3 vibration motors, we solder them together, and we attach them to each finger. And of course, in the thumb, you have only 2. So this is something very quick to make and testable, but then the problem is that you can't barely bend your fingers. So this is not going to work. So then we tried the second version. Okay, now we made a plastic PCB, and we solder the motors on top of that. Still 3 or 2 on one, and put it to that. Now it looks more compact. We were happy, but then unfortunately, this finger, let's say, mobility remained an issue. And we tried one more time. Now we don't want to use plastic. We go with sticker PCB. Now it's softer. But then the other problem is that we want people to be able to easily make it and maintain it, so it shouldn't get broken easily. But in practice, it's actually not easy to solder those motors on PCB. And when we have so many small PCBs, it's very difficult to repair and to debug as well. So then we dropped this idea of using this kind of PCB. We came back, so at the end we make a more clean version. We just put those, solder those, let's say, motors on the glove, and we move all the components, as many as possible, onto one copper PCB. So that integrated over 100 components at the end. And then we actually also use 3D printer to make kind of a case that could fit this PCB as well as the batteries. And you might have noticed that actually at the end we have 2 layers of this glove, and the inner layer is just a normal cotton glove, and then the outer layer has this motor. And the idea is that you could wash this inner layer when you give to somebody else to use. So our journey, and by the way, just to mention that we make this one as an open source. So it means that we have the PCB design and also the APIs available. And with these APIs, you could control the vibration intensity, the duration and frequency of each motor. And I also would like to mention that when it comes to, if you are a designer, you are probably more interested in the haptic design. So what we have learned that it's not just about the presence of vibration, it's more about how the vibration is patterned in time and space. For example, the raindrop can translate into gentle vibration on random spots on your palm, or if there is like a water flow through your hand, it could be implemented as a certain kind of vibration waves there. So there are many different ways you could program, so they are programmable. So our journey didn't stop there. And after that glove project, we also tried to create a haptic bracelet that could guide the stroke patients in their rehabilitation exercises, although it had limited success. And now we are working on our 3rd haptic project, and this time our aim is to create immersive virtual sauna experience. And this work is now part of the ongoing European Media and Immersion Lab project funded by EU, and the project started last autumn. So I would like to first show you a short video so you kind of can get a glimpse of our current progress. But I must warn you that this can just give you a visual overview of our project, because it's not easy, or maybe even not possible, to demonstrate this haptic feedback in the video. Yeah, and this is our first prototype. I will explain what they are. So it looks like, okay, just something there. Yeah. So how we actually develop in this one. So first of all, in this project, we first follow some very typical design project stages. So started by exploring the human tactile sensation, defining design requirements, making prototype, and then evaluating the user experience, and then repeat. And I think as you have done also in your design project, probably. But in this process, we continuously raise some research questions. So first, we sought to understand how individuals experience and express their thermal sensation of a sauna. And our doctoral student, Tim Moiscan, actually invited different people to the sauna. So he has been to sauna with, I don't know how many, 10, 20 people. Besides this verbal interview, he also employed these visual and tactile methods just to, to see how people can describe. Actually, you could imagine it's not so easy to just use verbal words to explain or to describe your experience. And what he has learned is that this sauna experience is highly dynamic and personal. Why we say it's dynamic? Because many people report that it starts with a very intensive, let's say there's an intensive start, but then there is some kind of graduate cooling effect after that, and you feel that there is a heat flow from top to bottom, and some people even say, I started to first feel pain, feel the pain, but after that I feel relaxed and happy. And of course, this varies also between subjects. But then when we got this result, we started thinking, now how to recreate this one. First, how to recreate all this. But meanwhile, when we were doing this user test, we started to explore the technical approaches to create a heat and cold. So how do you create a heat and cold? So we eventually settled on two options. So the first one is a heating pad made of conductive yarns. And the other one is a Peltier module. So how this Peltier module works is that it transfers the heat from one side to the other side when the current, when the electric currents go through it. And you can imagine that if you switch the direction of that, then this cold side and hot side will also flip like that. And we ran the X-ray experiment just to assess how fast the temperature would change and also how the voltage control would impact the results. So just to get to understand how the technology actually works. So then after that, the next challenge is where to place those Peltier modules or those heating yarns. And to answer this question, we actually need to address two issues. So first is how would people actually perceive the thermal sensation? And the other one is how can we recreate this heat flow? So from the literature, we have actually learned that the ability for the individuals to discriminate the temperature change depends on many factors, including, for example, where exactly the location on your skin the stimulation is applied, the initial temperature of your skin, and the amplitude of the temperature change, and also how fast you change that. And this is also kind of personal, because when we ran the experiment, we noticed that, let's say, somebody might feel it already when it's 38 degrees, somebody might need to wait until it's 40, so that's still different. And as I said, we ran some user tests. We want to validate this assumption, and they are validated. But meanwhile, we try to gather some crucial data. For example, the relationship between this temperature variation at different skin location and the corresponding receptor response. And why we want to collect this data? Because these data points would be instrumental in configuring our Peltier modules or heating pads or other actuators in the VR game. So we need to get data from there. So then there still has one open issue. So how can we simulate the heat flow across the body? Well, one might suggest that put the Peltier everywhere. But then from the wearability perspective, I really doubt if anybody else here, do you want to wear a garment with hundreds of Peltier modules? Probably nobody want to do that. The question is, can we minimize the number of these electronic components, like this Peltier module, because they are rigid, but without degrading the user experience? I can see audience start to think, how can I do that? And our current idea is that we would like to leverage the phenomenon of thermal referral. So how does it mean? So imagine that if you have this tactile and thermal stimulation and you apply them to two nearby locations on your skin, one thermal, one textile. And then people have learned that the temperature could be received also at the location where the textile is applied. Do you get that? So there is thermal, then it's textile. Yeah, so this does not relate directly to the dynamic movement of stimulation, but we can think in this way. What if the textile stimulation side continuously shifts? Would the temperature side also shift together? So we could implement the textile, for example, using simply like vibration motor. So what if we add some vibration motors to our garment? Can we utilize that to implement this kind of dynamic movement of heat? I don't have a clear answer for that because we are still working on that. But we wish that we would have this garment ready for the user study in spring. And if you are interested in that, welcome to join our user studies as well. So you will experience it firsthand. Yeah. And once we have the garment, as I just said, we will then shift the focus to the evaluation of user experience. And in this case, we would like to emphasize the sense of immersion and realism, and also your emotional engagement in this case. So we are not just going to ask you some questions or ask you to fill out some, let's say, questionnaires after the test. We would also like to be able to measure, for example, your emotional status or your physiological signals during the test. Yeah. And another big topic we also plan to study next year is that can we utilize the AI in haptic design, especially for personalized haptic design? Because we know that this haptic experience is personalized. And when we deploy this kind of system, how can we make it personalized? And if we apply the AI there, we expect the AI to be able to automatically configure those Peltier modules or other actuators based on the user's preferences and the context of the sauna experience. And here, now, for us, the biggest challenge is we don't know yet how to measure your experience in real time. Because if you imagine most of your user experience studies, they can't be done just in real time to tell how you feel that. Yeah. While the project is still ongoing, but we are very excited to already share our PCB design and our open APIs with the research community. They are all open source and can be reused for any research projects. And this is just a photo of this modular hardware design. So you don't necessarily need to use Peltier or vibration motor. You can replace it with any other actuators you want. But with this, it will be very easy for you to start with. You can just get our PCB design, go to the Aalto studio to create that. And we have also these APIs which could work directly in Unreal Engine if you want to develop any VR applications. I can see already some notes, so we will probably get some test users already. Yeah. So at the end, I want to make an advertisement. We are still developing this smart garment, and we are looking for a research assistant with the fashion and textile design background to join us to make our garment more wearable. So if any of you are interested, please contact me also after this event. And that would conclude my presentation, and thank you all for your attention.
Okay, we'll have a panel discussion in a minute, but for those watching online, there's going to be a short break in the streaming while we prepare the stage, so don't go anywhere. Okay, welcome back. We will be taking questions from the audience, but as a moderator, I take the liberty to start. You both have been involved in developing haptic devices, and so have I, actually. Maybe first we could talk about the term haptic. What does it actually mean?
You?
Yeah, I think as I said in the talk, maybe my definition is more this kind of traditional definition. So basically, I think this is something that could make, it's like you can feel, if you feel the object, you can feel the size, the shape, the texture, you know, the weight. So that's basically what I think the haptic is. But of course, I also think in some, for example, virtual reality scenarios. If imagine that it's a tourist game, you go there, you go to visit, let's say, an icy area, very cold. Even you are not touching anything, you should feel cold. And I don't know, is that does that also belong to does the same definition still work there? Yeah.
I would say not. I think I take my definition of haptics from the doyens of this research, Roberta Klasky and Susan Lederman, who define haptics as the ability to basically use kinesthetic and sensory information to detect an object. So it's like the visual system of the touch system. Yeah, if you're looking in your pocket for a particular coin, that's haptics, yeah? You're using that exploratory touch procedures to basically identify an object through touch. And that's my understanding of haptics. But what a lot of the haptic research people are just conflating haptics with touch. Yeah? That's not haptics. Exploratory procedures where I identify an object is my definition of haptics. I think there's some confusion in terms of haptics, a bit of a posher word than touch. But a lot of haptic technology is stimulating somatosensory systems. So the skin doesn't just have touch receptors, of course. It's got thermal receptors, pain receptors, itch receptors, chemoreceptors. The combination of all of those inputs defines body sensation. And the thing about touch, of course, is it's very difficult to do it virtually. Vision and hearing are easy to fool because you can fire photons and sound without having to actually do any physical contact. But touch needs that, which is obviously where your devices are really exploring that ability. You know, there is a possibility. You know, we did some brain imaging studies where we put people in a brain scanner and we showed them someone doing that and someone doing that. And when there was actual physical contact that they were observing, their touch cortex would become activated by seeing touch. So there is possibly a window there. By seeing touch, you can feel it.
I've been asked before if we are trying to replace human touch. Is there a danger of this kind of dystopia where we would not touch each other anymore?
Yes, miss.
Haptic devices would do the job for us. What do you think?
I would say from the research into this little nerve fibre that's obsessed me is that, like vitamin T, if you deny getting that vitamin, there are serious consequences on physical, mental health and your immune system. That much we're now beginning to understand. So this idea of a touchless world, I find a little bit worrying. That's why this research, I think, needs to be broadcast in terms of the importance of physical contact, because these days it's, as I mentioned in the early part of my talk, there's certain cultural resonances. You know, there was something I had at a railway, this was a station in London. And this basically is a sign that's been pinned up. And it's saying, touching someone inappropriately is sexual harassment and not tolerated. I know in Chinese communities, everybody's touching everybody. And there's an absolute cultural acceptance that physical contact is a part of normal life. This is a move to demonizing it. And I don't know what you think, but it's scary.
I think this touch, you need to have a context.
Yeah,
even when we come
yes,
to the haptic interfaces. For example, the simple case, we made these simple vibration motors to kind of simulate the rain drop. But if you ask people to put the VR headset on and they see this kind of visual, like a rain dropping, and they will say, yeah, I feel rain drop. But now if you remove the headset, you repeat it. What do you feel? Nothing. Oh, it's just something vibrating there. And I think when people talk about this, it's also like in what context you apply this.
Yep.
And in the physical world, why, I mean, we cannot really recreate everything that happened in the physical world in the virtual world. And in our physical world, when you see people, when you communicate, so there are like other things going, like the other part than just the touch. And when they come together, they have different meanings. So I think first this has to, you need to have a context, and then in what context you use that, and yeah.
That actually brings me to the next question I had in mind, because human touch is not just touch; it's a multisensory experience, as you just described, with other kind of touch as well. If a person touches us, we can also see and hear and smell the person touching us. But based on experiments in the lab, like Francis told, we do know that touch that is kind of stripped off of all the social aspects does have a physiological effect. But if we think in real world, would it actually be possible to make a difference to human health or well-being with touch, which is purely just activating certain mechanoreceptors, and there is no social aspect or any other multisensory aspect to it?
I think, as you said, context is always so important here in terms of where that experience is happening. And clearly to isolate, another one of my favourite C5 is, the nociceptor. It kind of doesn't matter where you are and what context you're in, but if I stick a pin in you, you're going to go, ouch. So the primary afferent doesn't really care about the input. And the same with the C tactile afferent. If you stroke it, it's going to fire regardless. But I think there are a lot of processes top down that modulate the experience. And that's, I think, where the richness of this system needs to be understood. I mean, you'll tolerate someone giving you an injection if the context is for your own medical health. But if someone's sticking a needle in you for no reason, it's going to be far more painful. So context certainly matters. And the multisensory thing is also important in that we're not just talking about touch. That smell can alter it, and the other modalities. If you're looking at someone giving you an injection, it's different to looking away. So all of these other modalities, I think, come into it. But the point is, I think that it is to respect the fact that these systems developed in natural environments, which is that the one I showed you about that mother stroking that baby to get that resonance between heart rate variability and the mother and the infant. Martine van Poijvel, my colleague, was leading that research. If you try to do that study in one of these posh baby labs, nothing would happen. Yeah. The only way you get that sensitive data is to bring the mother and the baby into their natural home environment, and then you get these beautiful subtle signals being monitored. So we need to be careful. If you want to understand an animal's behaviour, you can't bring it to a zoo, stick it in a cage and think, because you're stripping away the complexity of all these systems that evolved over sometimes millions of years to shape that animal's behaviour. And it's the same thinking with my baby mattress. It's trying to replicate the environment of the womb in the incubator more reasonably to help the systems develop more naturally.
Yeah, but actually, when you mentioned this one, I just got curious. So if you make this mat, it just kind of mimic this kind of touch. Do you also try to introduce something else? For example, mother's smell, or maybe they feel mother's temperature and this kind of thing.
I've recognised the fact that to replicate that in utero environment, there's something missing as well, the vestibular system, because the mother's moving around all the time. Yeah, so that, and there are incubators where they'll basically rock, but the key one I think is this touch. But obviously you've got all the other effects that are happening with the baby, drinking the amniotic fluid. Obviously all these chemosensory systems are operating. So it's surprising that these tots at 22 or 23 weeks can actually survive it out of the womb in any case, but the medical profession is getting more and more slick. But I kind of wonder ethically, because the trajectory of development, as we saw with the Romanian orphanage babies, is not good. if that tactile, and it's the touch that mattered most in the way that the Romanian orphanage baby's development was enhanced. But yes, you're absolutely right. We need to take care of all the other environmental influences that brain needs in order to develop normally.
At this point, do we have any questions from the audience? Very quiet.
I have a really basic one, probably, and I was just wondering if like kissing is a form of touching or not, and yeah, that at least that, yeah.
That's an interesting one in terms of, I think human primates are the only ones that lip-to-lip osculation for any extended period. And I did do a study where I looked at the tactile responses on lip mechanosensors, and we picked up the same kind of preference for velocity tuning on the lips that also impacted to some extent. We would infer that there's a reward system allocated to that type of skin. But that's not hairy skin, and it's another conundrum, because this is, I think, determined as more glabrous skin, the lips. But no, I mean, it's a very interpersonal way of communicating. We got that amazing hysterical resonance where that Spanish coach kissed one of the the football players on the lips, and the whole bloody world got completely rocked into how inappropriate that was, which it probably was actually. But there's something about lip-to-lip contact, isn't there, which is very, very different in terms of the French do all this kissing on the cheeks. But, yeah.
And by the way, actually, at least in the literature, I think it's this year or last year, there was already articles about this haptic device for mouth. So that could be also interesting to see how it works.
Yeah, there is something about suckling behaviour which interests me. Thumb sucking, and vaping. There's a possibility. A friend of mine always used to think that smoking was just a surrogate for babies that weren't breastfed, who needed that sucking. Maybe there's a lot of sucker in sucking, and I wonder whether a lot of the vaping behaviours is because you're actually sucking something. And these bottles of water where the nozzle looks a bit like a nipple, so people, are they really just nurturing themselves in terms of the role of that kind of touch? And again, this system is all about regulating stress. Yeah, its main functional role is impacting the hypothalamic pituitary axis, which is your stress regulatory system. So at that level, touch is purely, beneficial in too many ways.
Thank you both for your talks. So there's one interesting question I had, since you talked a lot about mothers and infants and the sense of touch. So I was wondering, in many of the Western countries, they don't recommend co-sleeping with babies due to sudden infant death syndrome, but meanwhile it's practiced all over the world. So I was wondering if you have ever done any study related to it, or what do you think about it?
Yeah, that's a lovely question. I have a PhD student who's actually looking at co-sleeping, and she's coming in enormous prejudice against the danger of co-sleeping. And there is none when you look at the literature. In fact, I was told if you looked at where co-sleeping became demonized, it tracks back, and you can search this for yourself, to 15th, 16th century Catholicism, where because they practiced this inability to have any birth control, mothers were having more babies than they could care for, and they would confess in confession that they were rolling over in these babies and basically finishing them off. So that was one of the leads where co-sleeping became demonized. And in fact, even in North America, my student, who is American actually, there are some hospitals in North America, when you leave that hospital with your baby, you need to sign a document that you will not co-sleep with your baby. And again, you're messing around with 3 million years of evolution here. Well, you're absolutely right. You look at these so-called primitive tribes, they get up in the morning and they wear their baby, yeah? That's a part of their daily life. And what's happening here is that tactile interaction is being cemented and bonded. And now, of course, the impact, the emphasis is to get, as soon as that baby's born, stick it in a cot, stick it in a nursery. So no, I think the evidence really needs to be looked at in terms of how important co-sleeping is. Many mothers and parents will basically admit to doing it, but not openly. But I think it's certainly something, again, go back to natural behaviour. My father was brought up in the Gaubles of London in a very deprived area, and 8 people slept in one bed. So there's a possibility they were far more better developed than those of us who didn't. And culturally, there must be differences. Is China more?
Yeah, we are more, well, I can give you one example of my own story. I had 2 kids. For the first one, I followed the Western rule. So no co-sleeping. So the baby was always sleeping alone. And then the second one, we didn't follow this at all. And actually, the second one was a preterm baby. But always I slept with him. And it seems that he grew much better. And you can't say this is a preterm anymore. So I don't know, that's my own experience. So it somehow proves that probably this gentle touch or this tactile interaction would actually
probably
help. Yeah. You need to wait until they grow up to see the long-term effect. Yeah.
Well, we looked actually, one of my students did just a simple questionnaire study asking adults who were born preterm, and we scored them on a depression inventory and this thing called the autism quotient. The more preterm these adults were, the higher they scored on depression indices and autism spectrum. Not at the clinical level, but there was a definite parametric relationship between adults who were born preterm and their incidence, their scores on depression and autism and other aspects of touch. So it's an interesting avenue to explore, because the experiments, if you like, have been done. Hopefully, if we get touch put back, we may see an attenuation of those effects.
Thank you for the electrifying talks. I'm still wondering about the baby mattress and the example of the rats becoming more resilient to stress, and also the question of context. So I wonder, are there studies being made on the difference between the context of a touch? Are there rats being stimulated by maybe a robotic arm, and then by a tall man, and then a short woman, or different in different contexts? Is there any study I could look up?
I think there are a lot more unanswered questions than answered questions. And as I said earlier, I don't think this nerve really cares about what's stimulating it, but there must be contextual influences which amplify the benefit. And it's things like smell and temperature, etc. So I think there's definitely room for improvement. But what we have shown is that touch seems to be a primary modulator of these benefits of physical contact on development. But I think we need to take this story. One thing, by the way, about this incubator mattress, and that the neonatologist I'm working with, made this point: we are not in any way replacing the mother. This device is basically, it's really targeted at very preterm babies, where the skin is so papery that they couldn't be touched at all in any case. So this device should show its benefits very quickly, measuring these epigenetic markers, how environment shapes the expression of various genes, are happening really quickly. So just taking saliva samples, we'd get some very clear indications of those that got standard care and those that got, the magic mattress should be showing significant improvement in many developmental markers. But it's new. This stuff is relatively new. So we're trying to bring more and more people into the cathedral or into the church, to basically explore this system more. Because, as I said, all this stuff with this so-called social media stuff is just nonsense. There's nothing social about this. It's antisocial in terms of the natural behaviour that we're now moving into, a touchless world, which is, I wonder how healthy that. Well, it's not going to be healthy. Simple as that.
Any more questions from the audience? One back there.
Since you have a lot of this stuff in open source, do you think that there's like any way that we could really escape the tech monopolies of Meta or Google or some such like proprietary structures that would own the universe if this were to happen? Another smaller question, why haven't you cleaned up the wires in the pictures? Like, you need to make them more aesthetic. They're a design disaster.
Yeah, so, well, I don't think those companies with their proprietary design would easily open source. At least in the next couple of years, these haptic devices are probably still going to be very expensive. And if they make it open source, we have so many very smart students there. You know, you can easily create your own one. I'm afraid then because for developing these haptic devices is very expensive also for the companies. So that I don't think that's going to happen very soon. The reason we make this open source, we really just want students and some researchers, can save some effort so they can start to play with that. As you can see, they are always the student work. And when we also came to this idea, hey, look, there are a lot of wires. Can you replace this wire even with conductive yarn? Yeah, in the production phase. That's usually the answer we got from students. But this time when we are making this smart garment for virtual sauna, we want to change this. That's why we are hiring people with fashion and textile design background, because often we notice that the designers, they cannot let some very ugly stuff go. So we do need people like that to join the group as well.
There's one question back there.
Yes, so I was wondering, with the brain development of touch, could it be more, let me think, would it be very beneficial, for instance, in preschool and primary school studies to implement touch more into the studies? Because currently in those kinds of studies in schools, touch is very much demonized, and it's had an effect on students and pupils, which I noticed myself when I was teaching very young children, in a sense that we started holding these relaxation sessions for them, where we'll just go and touch the soles of their feet slowly, or their head, massage their heads, and after that they were more calm. They just sucked in more information during classes. So could it be and their grades went up, so would it be more like, would it be a good avenue in teaching, for instance, to introduce all of these haptic senses and virtual reality and take more of a physical form of teaching, in a sense, be more beneficial?
That's a fabulous question, and once again, it's something that I've been looking at. I work with this lovely lady called Jean Barlow, and she was a teacher, but something like 20 years ago, she had realized through her own experience that physical contact between children was making a significant impact to their development and their behavior. So just Google Jean Barlow. But nobody listens to her because she has no data to actually support what she knows intuitively. But what Jean does is she goes into a class of 6, 7-year-old kids, and she does this peer-to-peer touch protocol, where one child will basically stroke the back of another. And she's playing games like, an eagle, an elephant, but one kid strokes the back of another, then they reciprocate. That child then strokes the back of the stroker. Not only are these children learning how to authorize touch, this is done in a very consensual way where one child is allowed, given permission to touch the other. But as you've so intuitively noticed, when a teacher gets trained in this peer-to-peer touch, these kids' behavior completely chills out, It's just like my rats, The rats that have the gentle touch. What we now know is that mechanism is absolutely critical in the way that these children's behavior basically works out throughout their time in school. And what we've done with this study is try to replicate the rat study, where we went into one classroom and the kids were trained in this velocity tuning, peer-to-peer touch. Another school, it was done quickly, just to try and replicate the rats. And we were taking cortisol samples to try and give these kids some kind of mild stress test, like a maths test or an English test. So the fast touch, slow touch group both get this stress test. And what we're predicting is that those that get this gentle touch at the CT preferred velocity will be far more resilient to the stress of this maths test. But it's been an absolute nightmare working with the schools because of the complexity of some parents won't sign informed consent, no one's touching my child. And these teachers are all very busy. I'd like to do it here, actually. I'd like to do it somewhere because it's so simple, yeah? And the rat study, to me, was phenomenal, yeah? This vitamin, you don't need to take it every minute of the day, yeah? Those rats just had 10 minutes of this. These children, I've called, I don't know, my generation remembers in the UK free school milk, yeah? Every kid was given free school milk because of, the post-war deprivation, etc. I call this peer-to-peer touch the new school milk, yeah? We now no longer need to worry about their physical health. We need to worry about their mental health. And if this were implemented in every school, 10 minutes every morning, I think it would transform the lives of these kids. So somebody should do it, please. No, great question.
Yeah, and I think that's also really big cultural difference. Because I remember when I grew up in China, so when we were at school, when we go out, the teacher say, hey, now go. Really like so-called hand in hand, like two kids are hold the hand like this. And here, if you're on the street, you see some daycare, finished daycare, they go out, they have a rope. Everybody hold a rope.
Tethered.
Yeah, and the first time I saw it, I was thinking, why do you need this one? You can just ask the kids to hold the other one, then that's all.
No, we really are losing touch. I mean that, metaphorically and literally, we are losing touch. And the neuroscience has to be the evidence that changes people's attitudes to what's going on here. But it's serious.
Do we have more questions from the audience?
Yes, hi. Just out of curiosity, I know that there are plenty of textile and fashion clothing designers in the audience, and I was thinking that our bodies are in the constant interaction with textile materials as part of our everyday life practices. So any thoughts on that kind of like how that might influence, or kind of, because of course different materials might have a different kind of cause different sensations, and maybe something feels itchy, something feels, I don't know, more pleasant, and we are moving inside of our clothing. So any thoughts on that how that could be considered?
There's a lot of work on intelligent textiles these days. I mean, actually, you take me back to my childhood. I could not bear wearing woolen trousers. Yeah, it used to drive me nuts. Interesting point, by the way, I should make, that not everybody likes to be touched. It does somewhat annoy my wife. I'm not particularly cuddly. And in fact, I'm not saying I'm fully autistic, but many autistic people do not like gentle touch at all. The touch is actually more aversive than it is rewarding. So we need to look at the heterogeneity. Different fabrics may be engineered in a way to optimize the contact. Because there's more of these nerve fibers, by the way, which wouldn't surprise you, on the body parts you can't get to. So the back is more densely innervated with C-tactile afferents, and who doesn't like their back being massaged? So it's nature's way of getting someone to sort of groom your back. But no, the fabric stuff, you'll know probably more about that, you.
Yeah, so I think if you think this garment like that, more like a functional garment, then, for example, when we are designing those haptic interfaces, that is something we have not studied so much, but I think that could also become one, you can call it design material, whatever, because now we are usually using all kinds of motors, this type of thing. But if you could take into account some textile, because it can give you different sense of texture like that, that could help. But we have not studied that. And now, for example, we try to use these heating yarns. And when heating yarn versus the Peltier module, obviously Peltier is just, rigid. and this kind of heating yarn is something you can wear. And you could put it on wood, on cotton, like a different material. You can also design whatever way you want. So that actually gives different kind of sensation already. But we need to really study more that, and we will need also help from neuroscience to understand why that makes difference.
Everybody needs a neuroscientist.
Yeah, why?
I got this analogy. The receptors in the skin, there's about 20 types of mechanoreceptors, thermoreceptors, etc. And there's some interesting properties of how those sensory systems integrate input. A classic one is wetness. Yeah, there's no nerve fiber in the skin that detects wetness. So if I put my finger into a glass of cold water and I cover it with a rubber membrane, people feel wet. If that water is warm, people don't feel wetness. So wetness, perceptually, is the combination of temperature receptors and touch receptors. So the brain is encoding those two different inputs as this thing called wetness without any receptor for wetness being there. A lot of what we experience is integrated information, how the brain's perceptual systems. Another classic one is temperature. If you put a cool stimulus on the skin, it feels cool. Put a warm stimulus on the skin, it feels warm. Put them both on together and people experience burning pain. Now there's no burning pain there. There's a warm and a cool stimulus. But the brain has interpreted those inputs as being hot pain. And I call this my notes chords. Yeah? Each of these inputs is like a note. And when you put two or three together, you get a chord, like wetness or like pain. So there may be opportunities. Brains are not non-linear systems. They're not taking that input and religiously just interpreting it. Like the example of wetness. It's a combination of two separate inputs to develop the percept of wetness. So there's a lot more, as you say, neuroscience will sort it.
And actually, the example you just gave that, I was thinking that because in our sauna experience, somebody reported the pain. Could it be caused by this?
No, you may be activating this system as well.
Yeah.
Yeah, understand the mechanisms, and then let's say we can play music on the skin, would be the analogy. You need to know more about the receptors. That's why those Nobel Prizes for the mechanosensory piezo channels and the TRPM8 temperature channels are very important. When you put a chili in your mouth, it activates a particular receptor system on the tongue that would normally be excited by a hot stimulus. So the brain doesn't know any different. The chili has basically, at capsaicin, has activated a receptor that would normally be detecting heat, and the brain experiences heat, but there's no thermal stimulus there, but you're tricking it by laying down a ligand which activates a hot sensing nerve. The same with menthol. Menthol will give you the feeling of coolness, but there's no thermal coolness there. There's another receptor called TRPM8, which activates the cold sensing neurons. So there's a lot of interest in this. Is hard-nosed molecular neurobiology, though. I don't know how long it took David Julius to discover the TRPM8 receptor, but it was a very long time. It's big science.
There's one question back there.
Yes, thank you. I have a question about the relationship between touch and knowledge and how we develop understanding of the world through touch and taking decisions based on haptic experience. And asking that also because in the field of textiles as well as other fields that closely related to materials, there's a constant way of taking decisions and understanding through sensing, touching, weight, texture, etc. So I don't know, what experience you have about this relationship.
So basically, you mean like what you sense, and then how you actually actuate if you use the interfaces. Is that?
Yes. Yeah. And how you know through that.
Actually, that's the difficult part in our work. Because usually, let's say for engineers, when we need to sense something or use sensors to measure something, no matter it's the environmental, like a status, or it's your own physiological signals that you could always measure. But then there's a thing like that sometimes we don't know what these signals really mean in terms of your experience or how people really feel. And that's what I mentioned in my talk, that we would like to find something you could measure, like some quantitative metrics that you can measure in real time to tell the relationship there. And from there, we figure out that, hey, when we try to, for example, control the haptic interfaces in this or apply this kind of stimulation, we observe this kind of physiological signal. And this means that, the experience is like that. But we don't know yet how we could actually quantify that. And that also makes it challenging to directly apply, for example, AI technology there.
We probably have time for a couple of more questions. Are there any more from the audience? If not right now, I could just quickly go back to that question about the different materials and clothing. I don't, of course, have answer for that either, but just made me think that last summer in a touch conference where Francis was there as well, I met a lady who works for, I suppose, Neuroscience department of Chanel, but that was for cosmetics. But I don't know if they study the fabrics and their clothing there as well. But that kind of research is done there, and they do consider these things.
Yeah, actually, in my very long life, I did
Yeah.
spend 8 or 9 years working in industry for a company that made what I call grooming products and feeding products. It was Unilever. And you wonder, what's a neuroscientist doing in an environment like that? I had a ball because I boiled down their business to, at that stage, something like 7 billion primates feeding and grooming. And this is where I made the argument that grooming behaviors are activating these nerve fibers. Yeah. So whenever you're applying, the cosmetic cream, you're basically activating the CT system. You're regulating stress. So you've got a real link here, and many of these companies now are becoming more and more interested in the fact that grooming isn't just to look good; it's inadvertently making you feel good. Yeah, depressed people by and large give up on care of body surface. They stop grooming. I'm not suggesting that depression can be cured by grooming, but nonetheless, there's clear evidence that the less you, and this nerve fiber, by the way, will respond to self-touch. So a lot of grooming behaviours are actually part of a normal process, I think, of regulating your mental health within the natural levels of just feeling good, basically. So no, I think there's some interesting parallels there in terms of research funding, where these companies are getting very interested in the underlying mechanisms that drive these sorts of behaviours, as you saw at the Festival of Touch meeting. I want to say one final thing about the despots in our world, by the way. I'm making no excuses for them. But if you look at the early life of people like Stalin, Hitler, Trump, Putin, they all had brutal upbringings. Yeah? None of them was effectively cared for or loved. They all grew up in very, very negative environments, which links to that guy James Prescott's view at NIMH, that early life lack of nurturing touch can have a devastating impact on people's subsequent behaviour. No excuses here, but there's an interesting correlation. Many people that grow up in care homes, again, develop drug-related behavioural problems, etc. I'm pinning an awful lot of sort of utility on this nerve fibre, but the more we know about it, the more exciting it becomes.
I think we are running out of time here. We can finish with Francis's words. So touch your children so that they won't become dictators. The world will be a better place. So thank you all for joining us. The next Creative Technologies seminar will be held in December. So we welcome you all back then. Thank you.